Hope everybody join. I think how many participants? 52 participants still join. Okay. How many total? How many total participants in your class? Anybody knows? I think we will start now. So, am I audible?
Yes.
Yes, ma'am.
So, good morning, and I wish you a very happy Independence Day to all of you.
Thank you, ma'am. Same to
Thank you,
you.
ma'am.
Thank you. So I chosen this day because from 7 days I was busy in my faculty development program, so I couldn't find time to get to take the lecture. So now 2 days we are having, like today and tomorrow. So we will have these difference equation lectures. In these 2 days, I will tell you what is the overview and what is the introduction of that topic. And then after 2 days, you can decide, means whether you have to choose lattice theory or you have to choose this difference equation. Is that okay?
Okay, ma'am.
Okay, ma'am.
So I hope all of you are fine and your family members are also fine.
Yes, ma'am. Yes, ma'am.
So let me share my screen. So only one or two persons can unmute, and they can, if I ask something, only one or two can unmute and they can give reply. Okay. If everybody unmute and starts talking, it will be disturbing. So
Okay, ma'am.
whether you have filled your option form, that lattice theory or difference equation.
Yes, ma'am.
Yes. Yes, ma'am.
After these 2 days also you can edit, okay, and you can change if you have opted a difference equation, and if you want to opt for lattice theory also you can opt, or if you want difference equation, that will be your choice. But wait for 2 days. Let me introduce you this subject. Already Reddy sir has been delivered 3 lectures, I think, on lattice theory, 2 or 3 lectures, and
Yes, ma'am.
he discussed about overview of lattice theory, syllabus, and all that things. Now you know what is that. And now I will, in these 2 days, I will give overview for difference equation, and then you can decide. Okay.
Okay.
Please join with only one device. Okay. Don't use simultaneously two, like desktop and mobile. Don't use like that. I am seeing here too, this Supriya Cornula is joining 2 times with 2 devices, I think. So use only one device. So let me share my screen with you. Whether you are able to see this screen?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And okay. So I am also giving like this using pen tablet first time. So it will take some time, okay, to adjust for the pen and all that things. Two people in waiting room. वेटिंग रूम में तो उनको कैसे लेना है अभी?
ये हेलो वो निकाल
इनेबल वेटिंग रूम।
वो अभी ऑटोमेटिक ज्वाइन होता है। अभी शेयर स्क्रीन कर सेलेक्ट कर सेलेक्ट नहीं हुआ।
Okay. So this is the title of our paper, difference equations. You can see it.
Yes, ma'am.
Okay. And its code is MATHE 311. So first I will show you what is its syllabus. So difference equations, you may be hearing this first time, this name, or you have come across two difference equations.
First time, yes.
BSc, maybe numerical equations.
Numerical analysis.
In numerical analysis, difference equation like delta operator, this delta operator, like this, delta y. Whether you have gone through this?
Yes, ma'am.
Yeah, so this delta is called as difference operator. Okay, so I will introduce you this later on. First we will see what is the syllabus. Okay, so what is the course objective for this paper is we want to learn here linear non-linear difference equations, and also we will use them to model real life problems. In this also we will check how to check the stability for that various models also. And these are the outcomes for our syllabus. Like in first unit we will learn difference calculus first, then in second unit linear difference equations and how to solve them, and then in third unit we are going to learn Z transforms. You all are familiar with Laplace transform and Fourier transform.
Yes, ma'am.
So in this you are going to learn about this new transform, Z transform, and how you solve like differential equations using Laplace transform or Fourier transform. Like that we have to solve here difference equation and use with the help of this Z transform. And we have to check we will learn stability theory in unit 3 for linear systems, and in unit 4 we have to study in detail phase plane analysis, Floquet theory, and nonlinear systems, stability theory for nonlinear systems also. So this is the detailed syllabus. I will share this PDF with you. Okay, so I am not going in detail. You can just have overlook on this syllabus. And this is the textbook. Difference Equations, an Introduction with Applications by Walter Calle and Alan Peterson. This is by Academic Press. Okay. There are reference books also, but we will stick to only this textbook, which will be our main reference book. Reference, or it is textbook, so we will stick to this only. Okay, for any other examples or something, you can just refer the cyber Iliadi also. This is good book, and Pundir and Pundir. If you want some more examples, you can go through these books, but I will stick to this because this book contains many examples as well as theoretical as well as many examples and exercises also. So that will be sufficient for us. I will share this PDF book PDF also with you. Okay, so now so now I told you what is syllabus, like difference equation, then linear, non-linear, and stability theory. That all things we have to see in this one semester course. In your BSc and MSc, you might have learned differential equations, right?
Yes, ma'am.
Yeah. So what is differential equation? Can anybody tell me what is differential equation? Because this is a parallel theory, like whatever you have learned in differential equations, similar will be there, only like little bit difference will be there, because this is difference equation and that is, see here, this is difference and that is differential equations. I think everybody is familiar with differential equations.
Yes.
In your first semester ODE you have learned, and in your second semester you have learned partial
PD.
equations. Yes. In that linear and non-linear, linear I think only, no? Linear, non-linear also you have learned. Can anybody give me response?
Differential equation gives the relationship between two variables.
Two variables only.
Containing
One
and
more
functions.
function.
One and more dependent variables.
One and more dependent variables. Any other?
A differential equation is a equation that related one and more function and their derivatives.
Yeah. So derivative is important, no? Otherwise, if only variables are there, it is just an equation, right? Like say ax square plus bx plus c, or you can, this is equal to 0, or you are saying some x square plus y square is equal to 0. Two variables, it is a function f of xy. This is like just f of x, right? So these are just equations. Yes, these are not differential equations. When it will be differential equation, if it contains derivative also.
Derivative.
Yeah. So what is derivative? What derivative represents? What is differential equation? It is an equation that relates one or more functions and their derivatives. So in real life applications, this functions represents physical quantity. Physical quantity means you can say pressure, mass, density, or anything, investment, anything, any physical quantity it represents. And what derivative represents? Derivative, if here you say, if we represent like dy by dx, so what is this y and what is this x? It is relation of dependent and independent variable also, no? Dependent,
Yes, ma'am.
dependent variable,
Y is independent.
Why?
y is depending on x.
X.
Dependent variable here. I am writing dy by dx means y is changing. Y is dependent on x. X is independent variable. Okay.
Yes,
Differential equations, we have to
Yes,
be
ma'am.
very careful about the dependent and independent variables.
Independent variables.
Yeah. So suppose this is my function y of x. So y, this x represents what? Physical quantity. Any physical quantity. In real life applications, I am saying, because when we use in our syllabus or something, we just use as variables, known function and unknown function and like that. But in real life applications, when we are using differential equations, they represent physical quantity, and this y of x, okay, this y of x. And what is its, this dy by dx? This is the derivative. It represents, what is represents? What is the
Change
derivative?
with respect to X.
Yeah, change in that physical quantity. Okay.
Quantity.
Yeah. So it is a derivative is nothing but rate of change of that physical quantity.
Quantity.
Yeah. And if so, what is differential equation? I will just give differential equation is an equation that that relates one or more functions and their derivatives and their derivatives. Okay, so this is differential equation, and you have already familiar with this and how to solve them also. Okay, so for example, you can say d2y by dx square plus 2 times dy by dx plus please don't write anything, plus y is equal to 0. This is differential equation. Another example I can give is, you can represent like this also, y double dash plus 2 times cos x
2y dash.
is equal to some say function of x or some sin x, like that also I can write. Okay, this is also differential equation. Let me write some examples and then we will see classification. Okay, first let me go through okay, d2y by dx square 2 dy by dx is equal to 0. Okay, again which I can give dy by dx plus y is equal to say cos x. Yeah, so you can see here 4 examples of differential equations. Whatever equations I have written there, these are differential equations. Yeah.
Yes, ma'am.
Yes.
Now,
Yes, ma'am.
which you might have learned classification of differential equations also.
Yes, ma'am.
Yeah. So, what is the main classification of differential equations? I will go first. We will have classification.
First order.
Yeah, differential equations. I will write. First order. I am asking classification. Classification of differential equation. What is main classification? Ordinary differential
Ordinary differential equation and partial differential equation.
equation. So what is ordinary differential equation? Which contain differential
One or more dependent variables.
one or more.
One.
Dependent or
Only
one
independent.
one.
Only one. Let me see how. Now, only one independent or dependent? How many dependent? How many independent variables in ODE? Ordinary differential.
Only one dependent. One dependent and one independent variable.
One dependent.
Only one independent variable.
Only one dependent or independent?
Independent. Dependent.
Dependent, only one dependent variable.
So whatever examples I have written, whether they are ordinary or partial.
Ordinary.
So how many
Ordinary
different variables here? first equation, how many dependent and how many independent variables?
Only one
One is dependent, one is independent.
dependent.
Yeah. In second also, one is dependent,
Yes.
one is independent. This also, right?
One is independent.
Only one dependent, one independent. Let me write fifth. Uh,
आम्ही तर दोघच आणि काय फवारायचं हा देवकडे ही आहेत त्यांचे घरची माणसं आहेत आपल्याला ड्रिचिंगला तर 10
what about fifth one?
किती ड्रिचिंग केले त्यांनी तेवढ्याला 5-6 माणसं सारखी
What about
राहायची
fifth one? D2y by D2 square. Plus 2 dx by dt, which is equal to cos t. Can you see this?
Yes.
Fifth one.
Ma'am.
So how many dependent and how many independent variables here?
Two dependent and one independent.
Two dependent and
Independent.
One independent variable.
One independent.
yes, right. So which are dependent? Y and x are dependent variable, and they are depending on t. Right?
T.
This t is my independent variable. Right? This t is my independent variable, and this y and x are dependent variables.
Dependent variable.
So whether this is ODE, one.
ODA.
This is ODE, ordinary differential equation. Yes. In ODE, it contains only one independent variable, right?
Variable.
Only one independent variable. Let me erase this. So Mayuri Gunde has raised hand. Whether you want to ask anything? Mayuri? So ODE contains only one independent variable. Okay. So differential equation containing only one independent variable is called as ordinary differential equation. And what is PDE? It can contain
More than one.
Two or more than
Independent variables.
Two or more than two independent variables.
it contains more than
One independent
one. More than one independent
variable.
variables. Right? So we are not going into PDE here. So we are concerned about ODE now. So you know classification of ODE. So first semester
Yes, ma'am.
about ODE, ordinary differential equation. It is an equation which contains only one independent variable.
Variable.
What is its main classification?
First order, second
No.
order.
So first order, second order, third order, nth order. So how many? That is not a classification.
Homogeneous
Linear
and non-homogeneous.
Linear and non-linear.
Linear and non-linear
Non-linear.
ordinary differential equation.
Equations.
So what is linear differential equation? When we say it is linear differential equation,
Is homogeneous.
Degree is 1.
degree is 1. And non-linear means it will have degree more
More
than,
than one.
is it? So, okay, I have given this, okay, we have written here. This is good. And then Blackboard, we are having this one with us only. Okay. So you can see these 5 differential equations, no? These are all ordinary differential equations. Now, can you classify which are linear, which are non-linear? Degree and order, I think everybody know.
Yes, ma'am.
Yes, ma'am.
What is the degree and order of this differential equation?
Order 2 degree 1.
Order 2 degree. Right. Here,
Order 2 degree.
order
Order 2 degree 1.
2 degree 1.
Second order. Order 2 degree 2 in third example.
this
Order 2 degree
Order
2.
order
1 degree
1
1.
degree.
Yeah. So, which are linear here? Talk about 4.
First equation is linear.
First,
Second also linear.
linear and non. I will write here non-linear. And you tell me means whether this is linear. Yes.
Yes, ma'am.
So what about this second one?
Linear.
This is also linear.
Linear.
Yes.
Yes.
Okay. What about this?
Non-linear.
Non-linear.
This is non-linear. Okay. And what about fourth?
Linear.
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 I will fourth also I will write here linear. This is not. So let me give one more. Dx plus y equal to 0. What about this?
Linear.
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 Yes.
You can see properly, no? Like dy by dx plus cos y is equal to 0. You can see this?
Yes.
Yeah. So whether this is linear or non-linear. Because if, why I am going to through basics of differential equation, if you know basics of differential equations, then for difference equation also parallel theory applies. So knowledge of differential equation is very, very essential for difference equations too. So I am checking what about differential equation. So whether this is linear or non-linear.
Linear.
How many of you here? I can't take poll. Otherwise, I might have taken poll here. Linear. Why you are taking that much time? What is the degree?
1.
Degree 1, order 1.
1.
Degree 1, order 1.
Yes, this is linear equation.
This is linear. Think of this again. Anybody is there who is saying non-linear?
No.
Anybody is there who is saying non-linear? Everybody thinks this is linear, right?
Yes, ma'am.
So how many participants? I think 52. 52 participants we are having. 52 are saying this is linear. Yes? If anybody is saying no, then please you can unmute and say it. Otherwise, I will think everybody is saying linear. I am saying this is not linear. It is non-linear. because of this term. What is this? Cos y. Whether this is linear term or non-linear term. Cos y. Trigonometric function. What is this y? Y is dependent variable. Y is dependent variable and this cos of y is non-linear term of dependent variable. Are you getting what I want to say?
Yes, ma'am.
Yes, ma'am.
So suppose if I am having this dy by dx plus cos x is equal to 0, then this will be linear.
Yes, sir.
Linear. Means we want linearity or non-linearity of differential equation doesn't depend on independent variable. Means linearity or non-linearity of functions of independent variable. Only we have to check whether that derivative dependent variable and its derivatives, whether they are in linear form or not. Is that clear?
Yes, ma'am.
Dependent variable and its derivatives. Dependent variable y and its derivatives, if they are in linear form, of if all terms of the differential equation, if they are all in linear form, then I will say that is linear differential equation. Otherwise it will be non-linear. You can say here cos y. Cos y, this is non-linear term. Yes.
Yes, ma'am.
Here also cos x is non-linear, but it is non-linear term for independent variable and we are not bothering about independent variable. Okay. In differential equations, linearity and non-linearity of differential equation depends only on the terms of dependent variable.
Dependent
So
variables.
if dependent variable and its derivatives, if they are in non-linear form, if one term is also in non-linear form for dependent variable or its derivatives, then we say that differential equation is non-linear differential equation. Is it okay?
Yes.
Is it okay for everybody?
Yes, ma'am.
Non-linear.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, can you tell me now? I will give more 2 examples. Say, so now can you tell me which is linear, which is non-linear?
First one linear.
First one is linear. Sin x is there, but it is non-linear term for independent variable. So
Yes.
this is linear only. What about
Linear.
second?
Non-linear.
Why it is non-linear? Which is the non-linear term here?
Y double dot.
Y dash square. Because square may also
Non-linear.
linear. What about this? Y dash plus sin y
Non-linear.
Non-linear.
because of sin y it is non-linear. Okay, so I think now everybody might have clear about linear differential equation and non-linear differential equations. Is that okay?
Yes.
We will go further. Wait. Now, what is another classification? I will again write differential equations. So, linear, non-linear. So, in linear again, then what are again sub classification?
Homogeneous and
Yes,
Yes.
non-homogeneous.
Non-homogeneous equations.
And yeah, so for non-linear also it is homogeneous, non-homogeneous. Okay, so homogeneous and non-homogeneous. So
Non-homogeneous.
linear homogeneous differential equation. So nth order linear differential equation, you can say nx. Erase this. Nth derivative yn x anx y raised to nx nth derivative of y. Okay, n minus 1 of x y n minus 1 the derivative of x plus and so on. A0 of x y0 means or first let a1x y plus a0x is equal to, again you say, f of x. This is the general this is what? This is the general form of nth order linear differential equation. Okay, this is the general form of nth order linear general differential equation where n of x is not equal to 0, then it will be nth order. Okay, n of x, this should be non-zero, then only it will be nth order. Okay, and this nx, n minus 1 of x, a1 of x or a0 of x, these are the functions of any non-linear or linear functions of x. It doesn't matter for us. Okay, but that will be nth order. This type of, this is the general form of, this is the general form of nth order linear differential equation. Okay, now homogeneous and non-homogeneous, how I can say it is homogeneous? When I will say it is homogeneous, it depends on right hand side. It depends on right hand side. If this f of x is equal to 0, then I will say this is
Homogeneous.
and if it is not equal to 0, then I will call it as
Non-homogeneous.
Is that okay?
Yes.
Yes.
Today we have seen classification of differential equation. Okay, I have shown you syllabus also for difference equations. Syllabus also I have shown. So here in BSc and MSc you have learned linear, non-linear. I think from 12th you are in 12th you have learned differential calculus, right? 12th or BSc first, second, third, differential calculus.
Yes, ma'am.
Yes,
So
ma'am.
in one semester course here we have to learn difference calculus also. For linear difference equation also we have to see. Then non-linear also is there in third or fourth unit, and then we have to solve them also. So this all things we have to do in one semester course, okay? But since this is parallel theory, we can go very fast in this. Is that okay?
Yes.
So tomorrow I will start with what is difference equation and where what are its applications in real life applications. Real life applications we will see. Okay, I think time is that Zoom meeting only 40 minutes will be there. Okay. Anybody want to say something? Um, Participants? Students, no participants, not participants, students. Okay. Is that okay today?
Yes, ma'am.
Today
Yes,
we
ma'am.
have seen differential equations and their like basics of differential equations. Now in differential equation, what about that or whatever variable will be there, that is continuous. Okay. Continuity should be there. But in difference equation, we can use discrete variable too. So tomorrow I will discuss about what is the difference between differential equation and difference equation, and then we will go with applications of various difference equations. Okay, is that okay?
Okay. Okay, ma'am.
Yes, ma'am.
So we will stop here today. Anybody have some queries, then they can ask, or otherwise I can stop. No queries?
No.
Okay, okay. Then we will stop here.
No.
You can start your video so that I can have a look. You can start now your video. Yeah, so I can see your faces. Everybody is fine, happy. Then I can because until and unless I see your faces, I am not thinking I am in class or. I told you to stop video because otherwise it will make disturbance and too much data also. I think nobody wants to show their faces. No, you don't want to show the faces? You don't want to see each other's faces also? Your classmates' faces? Okay, next time.
Okay, ma'am.
Okay, okay. So tomorrow we will have that.
Okay.
We can have come with nice dresses and faces.
Yes, ma'am.